When you think about AI workloads, we're thinking about a new type of a network that has different requirements from the traditional front-end network that used to support general-purpose servers. So when we talk about accelerated servers for AI workloads, and when we talk about the AI traffic, we're talking about the need for a low latency, losslessness, scalability, and all of that puts a lot of pressure on vendors to try to meet the requirements for the AI networks. I've been tracking Ethernet for front-end network for many years. And in the front-end networks that are used to support general-purpose servers, we've been talking about, speed upgrade cycles every 3-4 years, and now even every 4-5 years. When we talk about AI backend networks to support AI workloads, we're talking about 18 to 24 months of refresh cycle. We're talking about GPUs or accelerators that require already 400 or 800 gig, and soon they will be requiring 1.6T. And all of that puts a lot of pressure on Ethernet to keep up with the need in bandwidth requirements. So we're seeing the speed upgrade cycles in back-end networks twice as fast as in the front-end networks, which means every 2 years, we have to keep up with double the bandwidth, basically, for Ethernet, along with other requirements. It's not all about bandwidth in AI clusters. It's about latency, losslessness, congestion control, congestion avoidance. So all of those requirements are going to only intensify as the scale of the AI clusters is growing. So I don't really see this slowing down anytime soon, because when we look at the data growth and the number of parameters that AI workloads are dealing with, we're not seeing slowdown in the growth in the number of parameters, 10x every year. As you all know, when we talk about back-end networks for AI clusters and servers, InfiniBand has been the predominant technology. 80% of the market for switching was done by InfiniBand. And I would say mostly because InfiniBand was the only game in town. 2 years ago, when you had to make a decision, when the market was in a panic mode to basically build as fast as you can, InfiniBand was probably your best bet. We're seeing that changing. We're seeing that changing on the supply side and on the demand side. So on the supply side, all the Ethernet players are really making good progress in and introducing Ethernet products with improvement to try to meet the requirements of AI workloads. Even NVIDIA now is really has introduced Spectrum X, and they are really pushing Spectrum X Ethernet platform to the market. On the demand side, also, we're seeing few tailwinds for InfiniBand. So we're seeing the proliferation of non-NVIDIA accelerators, which have a natural affinity to Ethernet. We're also seeing hyperscalers having an increased appetite for Ethernet, and that's really driven by the desire to diversify their supply chain, plus the increase in the AI cluster scale. I'm hearing that the tendency is to think that Ethernet may scale better than InfiniBand. And so all of these tailwinds are really pushing Ethernet into AI backend networks. I've already published 2 reports for AI networks covering the size of the scale-out market from a switching perspective. I track InfiniBand and Ethernet share in that report. I track speed migration. We are on the second iteration on our version of that report, and a lot has changed within the last few months. The first iteration was published by end of 2023, and the latest one was published in July 24. And of course, there is always also the front-end network. We also have market share tables there to cover the 20 billion market, existing market for Ethernet, which is the front-end network.